So most of chapter 1 is actually going to feel like a review because these would be concepts you would have seen in an intermediate algebra class, maybe even in a basic algebra class. So some of this will feel like review, but if it's been a while since you've seen any of these concepts, then it will definitely be a refresher course. So it's kind of nice to start with chapter 1 where, we bring back a lot of those concepts, which will help you obviously in the other sections as we move forward. So with section 1.1, we're starting out with talking about just how to solve linear equations. We'll look at equations that have rational expressions in them, and then of course, absolute value equations also. So anytime you are talking about an equation, you are basically talking about how two algebraic expressions will be equal to one another. So you can have an example like this where you have 2x minus 6 equal to 0, which is of course your linear equation in one variable, which in the standard form ends up looking like ax plus b equals 0. And you will notice we are putting a restriction on that real number a. We are saying the number cannot be 0. Because, of course, if you make the value of a 0, then 0 times x will end up becoming 0, and your x will disappear, which means you won't have an unknown variable anymore. So that's why we put that little restriction on that coefficient for x. Now, when you're talking about finding the solution for an equation, you're basically saying what value can we use for that x variable so that we can end up getting a true statement. And by true statement, of course, we mean the left-hand side of your equation should equal the right-hand side of your equation. So if you think about using as x equals 3 and plugging it into our equation, you end up getting 2 times 3, which is 6. 6 minus 6 will end up giving us 0, and you will notice we in fact do end up getting a true statement here at the bottom, 0 equals 0. So anytime you get a true statement, the value you used for your variable is successful, because that is going to become the solution of your equation. Sometimes we call them as roots. And basically we are saying that that number 3 is satisfying our equation. But let's say instead of using 3, you ended up using the number 2 for that x value. So when you plug that in, you will notice we end up getting 4 minus 6, which of course ends up giving us negative 2 equal to 0. And this is a false statement because obviously our left-hand side does not match the right-hand side. So anytime you get a false statement, that number is not going to be the solution of our equation. So basically that's what we are going to try and do here, is just figure out what values can we use in our solution set. So some of the techniques that we need to be able to use are going to be these different properties of equality over here. So, whenever you are working with equations, as you guys will be aware, you can add a number to both sides of your equation. You can subtract a number from both sides of your equation. And the idea of adding and subtracting from both sides, of course, is, to maintain the balance of our equation. Because we don't want to change the value of the equation. Obviously, we want to maintain that value. So whatever you do to the left-hand side, you end up doing that same thing to the right-hand side. You can obviously also multiply and divide the same number on both sides of your equation. We just have to be careful about the number that we are multiplying or dividing is not going to be equal to 0. Because if you multiply both sides of your equation by 0, we just end up getting 0 equals 0. And we didn't really solve the equation. We didn't try to find what our x value is going to be. Now, when we talk about dividing by 0, of course, division by 0 is undefined. So again, we will not be able to, find the solution for our equation. So again, just 2 little restrictions when you're multiplying or dividing on both sides of the equation. So we've got a couple examples here. So again, you should have seen those in the video, but I did want to pull up a couple examples here from your homework just to make sure you guys are comfortable working with these types of problems. So the first couple are just going to be about vocabulary, but let's look at this example over here. So if you guys have scratch paper or a notebook or whatever, you want to definitely bring that out and let me see what kind of solution you can come up with for this equation. Don't send me the answer just yet. You can type the answer into the chat window, but don't hit enter till I ask you to. So just get your answers ready. And when I ask you to, you can send it. So again, when you are ready, just type your answer into the chat. And when I ask you to, you can send it. Because I want to make sure everybody's answer comes in at the same time. If you're ready, go ahead and send your answers in. Alrighty, let's see, we've got a bunch of sevens. I've got a 2 in there. Let's see. Kalia, Isaac, Dalton, Daisy. Okay, Waylon. Micah, you got 21 over 13. Logan and Jacob. Okay. Michelle, alrighty. So a couple of you got a different answer than what your classmates did. Elijah, looks like you got 4.6. All right, let's take a quick look at this example because I'm not sure why some of you are getting a different answer. So we are looking at 13 plus 5z equals 8 times, in parentheses, z minus 1. So if one of you will tell me, how did you start this problem? What was your first step?
I multiplied the 8 times the z minus 1.
Yeah, very nice. Definitely. So you want to start by distributing that 8 inside the parentheses. So very good. We can do the left-hand side for now. We'll leave it as it is. And then when you distribute that 8, we will end up getting 8 times z, which is 8z minus 8 times 1, which will of course be 8. And then get your like terms on the same side. So to keep our numbers positive, we can go ahead and subtract that 5z, move it to the right-hand side. And then since we moved the 5z, we'll take this 8 to the other side. So we'll go ahead and add 8 on both sides. So these guys will cancel out here. These guys cancel out here. And let's see, you are going to end up with 13 plus 8. Okay, Elijah, you got 7 now. Alrighty, so that would of course add up to 21. And then on the other side, of course, you're doing 8 minus 5, which will end up giving you 3z. So when you divide both sides by 3, you should have your answer for 7. So I know one of you got the answer 2. And then Maka, you had 21 over 13. So I'm guessing you actually ended up adding the 18 and the 5 instead of subtracting that. Okay, I'm not sure how we came up with the 2. Daisy, do you know what happened?
Yeah, I made a mistake and I was combining, I think, subtracting.
Okay. Okay, so did you figure out where you went wrong then?
Yeah.
Okay, wonderful. Thank you. Alrighty, guys. So all we have to do now is just do a quick check in our little answer box. But something I wanted to show you as we're going through this, you should be able to see when you click on that little answer box, you have these little menu options that end up showing at the bottom of your screen. So if you have to type fractions, if you have to type exponents or, you know, radicals, they will always end up showing you this little menu option. So you will be able to type up, you know, whatever your final answer ends up looking like. So just something to kind of keep in mind. Alrighty, so let's check our answer over here. So just going to do that, and there you go. You'll have a couple different examples on just solving these basic equations. Now, the next thing I wanted to look at from 1.1 is just classifying what type of different equations you can come across. So you can see we have inconsistent, conditional, and identity equation. So when we're talking about an identity, we're saying it's an equation that is satisfied by every real number for which both sides are defined. So you can see these examples that you have up here. If you take 2x minus x and subtract that, you will end up getting x equals x. So obviously whatever value you will have on the left-hand side will be the same value you have on the right-hand side. So of course, every real number is going to be the solution set for this first equation. If you look at the second one, again, we've got 3x minus 1 equals 3x minus 1. So your left-hand side is exactly the same as the right-hand side. So again, every number that you put in for x will be the same for the left-hand side and the right-hand side. So both of these equations are what we call as an identity, and your solution set is going to be the set of all real numbers. Now with this third one over here, you are given x over x equals 1. Now if we go ahead and cancel out the x over x, you will basically end up getting 1. So this guy will become 1 equals 1. Now this is still an identity. The only difference is, since we have this x in the denominator, this denominator x cannot equal 0. So this x here cannot equal 0, which means your solution set is actually going to be all the non-zero real numbers. And using set builder notation, this is actually how we write it down. So we are saying x is all real numbers except 0. So x cannot equal 0. So even though this is an identity, there is going to be that one number which makes our denominator 0 that we cannot use, okay? So that's one type of equation. Now we also have conditional equations, and we are saying this is an equation that is satisfied by at least one real number, but it is not an identity. So in an identity, we talk about the set of your solution set being all real numbers. But in conditional equations, we're saying there's going to be at least one real number, but not all of them like we have in an identity. So if you look at this example over here, you are given 2x minus 6 equals 8. And the only condition that will satisfy this equation is going to be when x equals 7. And that's actually true also for this equation we saw over here, 2x minus 6 equals 0. The only condition that satisfies this equation was, of course, x equals 3. So this was also a conditional equation, and of course, this example here is also. Our third type of equation is going to be the inconsistent equation, and these are equations that have no solution. So if you look at the examples over here, we've got 5x equals 5x minus 2. So if I go ahead and subtract this 5x on both sides, you will see that that 5x will actually end up canceling out, leaving us behind with 0 equals negative 2. And of course, you can see my left-hand side does not match my right-hand side. So, and the other thing that happened here is your x variable disappeared because you don't have any x left behind. So these are the type of equations that we call as inconsistent equations that have no solution. If you look at the second example, you will see we are multiplying our x with a coefficient of 0. So you've got 0 times x, which would make it 0. And again, we would be left behind with 1 equals 2, which is again a false statement. So another inconsistent equation. And in the last one, same thing like the first one. If you go ahead and subtract that x, move it to the left-hand side, again, your x's will cancel out, leaving us behind with just 3 equals 5, which is again a false statement. So all of these examples are going to be inconsistent equations. So you will have questions where they're going to ask you to solve the equation, see what kind of answer you're coming up with, and then classify, is this equation an identity? Is it a conditional or an inconsistent equation? So we'll look at a couple examples for that. I also wanted to talk about equations involving rational expressions, so you can see the different types of examples you have up here. So again, all of these examples are part of your video lectures that you can look at. But the main goal here, when you're trying to solve these types of equations, is trying to see if you can find the least common denominator, and then you can multiply your entire equation by that least common denominator. And what this does is actually helps you get rid of the denominators. Now, with some of these examples where you have your variable in the denominator, there's going to be some number which is going to make your denominator 0. So we always need to remember to exclude those numbers from our solution set, because anything that's going to make your denominator 0 cannot be included in the solution set. So just something else you want to keep in mind as we are solving these examples. So let me pick another example from our homework over here. Okay, how about something like this guy here? So looking at this equation, you've got 1/2 x plus 1/6 equals 1/4 x minus 1/4. So you've got 3 different types of denominators, basically 2, 6, and 4. Can you tell me what our least common denominator will be, looking at all of these denominators over here?
Is it 6 and 4?
6 and 4? There's got to be one number.
Oh, well, I mean, once they added them up, that's what you mean. Never mind.
Okay, Keshla, you are saying the least common denominator should be 2. So think about it this way. It has to be a number large enough that can be divided evenly by 2, 6, and 4. It's got to be a number large enough that all of those denominators will divide evenly.
It'd be 24, right? Or, oh, no, 12.
Yeah, Maka, Noah, and Allison, Isaac, Jacob, yeah, you guys are coming up with 12. And that is going to be a perfect number because, like I said, 2, 6, and 4 should evenly divide into it. And what you can do is, if you just take all of these denominators and break them down into prime factors. So 2, of course, is just going to be 2 times 1. We can write 6 as 2 times 3, and of course 4 as 2 times 2. So when we're talking about finding the least common denominator, you can see how all of them have at least 1, 2 in their factorization. So you can take this 2 and write it down. Now, the remaining numbers, obviously there is no repetition in those, nothing is common in those numbers. So what we do here is just go ahead and include those also, and you can bring that 1 if you want. But obviously you will see when we multiply these numbers, 2 times 2 is 4, 4 3s are 12. 12 will end up becoming your least common denominator. So that's another way to calculate what your LCD will be. So once you have your least common denominator, you are going to take the entire equation and you're going to multiply it by 12, which means that 12 gets multiplied into each of these terms from our equation, and we will end up getting 12 times 1/2 x plus 12 times 1/6. On the other side, 12 times 1/4 x, and then of course minus 12 times 1/4. So when we do this, you can see we will be able to get rid of our denominators now. So 12 and 2, so 2 would go into 12, of course, 6 times. 6 would go into 12 2 times. 4 goes into 12 3 times, and then the last one would be 4 goes into 12 3 times again, yeah, because both denominators are 4. Okay, so after you cancel out, we got rid of all our denominators, so now you're just working with single terms. So now we will have 6 times 1, which will be 6x, plus 2 times 1, which will be 2. 3 times 1 is 3, and then of course minus, sorry, that should have an x on it. And then minus 3 times 1 is 3. And you will see once you get rid of those denominators, then again, it's just a simple equation that you are solving. So just like you did last time, type your answer in the chat, but don't send it till I ask you to. So let's see what you guys came up for x. And while you are working on it, I just wanted to point out, they are asking for an integer or a simplified fraction, so no decimal answers. Just type your answer in, don't send it till I ask you to. All right, go ahead and send it in, guys. Okay, so I'm getting a bunch of -5/3, -5, +5/3, okay. -5/3. All right, let's do a quick check over here then. So same thing, you want to get your terms, like terms on the same side. Okay, Teddy, you're converting that into a mixed number. Chloe, you went back to a -5/3, okay? Teddy, since they're specifically asking us for a simplified fraction, we're not going to convert it to a mixed number, but otherwise your answer is correct. But I know they will not be accepting mixed numbers unless they specifically ask for it. So we'll go ahead and move our 3x to the left-hand side, move that 2 to the right-hand side, and that's where your negative sign is actually coming from, because now you have -5 over here. 6x minus 3x will of course be 3x, and then when we divide by 3, we end up getting our -5/3. Okay. So let's do a quick check over here on our answer. We've got -5/3. Alrighty, there we go. So you will have a couple more examples with the rational numbers in them, but let's talk about these different types of equations we have, and then I'll show you where those other examples are. So identity, conditional, or inconsistent. What type do you think this equation is? Okay, I've got Dalton with identity. Maka, you're saying conditional. Jacob, identity, okay. Okay, Dalton, you're saying not identity, okay. Anybody else? Identity. Oh, I'm getting a inconsistent from Isaac. Conditional, identity. Okay. Alrighty, let's try and solve this and see what happens, because it may be that when you're just looking at it, it's not showing up. So just like you did in that previous example, you do want to go ahead and distribute that 2 inside the parentheses. So that will end up giving us, let's see, 2x minus 6, and then you have 2x plus 6. Now, when you try to get your 2x terms together, minus 2x will end up canceling out. And as you can see, you actually end up with negative 6 equals 6. So Isaac had the right answer, because as you can see, your x variable disappeared and your left-hand side is not matching the right-hand side. So obviously this leads us to the, so since this is a false statement, this is going to be an inconsistent equation. Alrighty, so since this is an inconsistent equation, remember they have no solution. So you will be selecting that last one over there, which is an empty set. We'll do a quick check, and then your second part is where it's going to ask you to identify what type of equation this is, and this is where, of course, we'll be choosing inconsistent. Okay. All right, let's clear this out. All right, so same thing. What type of equation do you think this guy is? 7x divided by x equals 7. Okay, Isaac, Daisy, Dalton, Tessa, okay, Jacob, Julia, Noah, Maka. All right, all of you guys are going with identity. All right, very nice. Because yes, in this case, you can see we have that x over x. If we end up canceling that out, you would definitely get 7 equals 7. So we know we will be getting a true statement. Additionally, because that x is in the denominator, we know that x cannot equal 0, just like you saw in the handout example I was showing you. So just be careful when you are looking at these type of examples over here. We will need to use option B, because you do have a restriction. It will not be all real numbers. X cannot be 0, so that's why you need to go with option B in this case. So we will select option B, and then again, the type of equation, this is an identity. So a quick check on that. There we go. So these were the type of equations that I was showing you in the handout. So again, look through the video if you haven't. Hopefully all of you have. I have gone over these examples in our video lecture, so you should be able to follow these examples to try and solve these type of equations. Now just be careful, because again, your variable w is in the denominator, so they are going to be at least one number, which would make your denominator 0. So again, you have to remember to exclude that from your solution set. So you have all the examples here are the same ones that you have, or similar to the ones you have in your handout. So you should be able to work through those. Now, the next type of equations we want to talk about is absolute value equations and how to solve them. But before we look into, how to solve these equations, can you tell me, what do you understand by an absolute value? What does absolute value mean?
Doesn't it mean that like negative doesn't matter or positive? It just wants like the whole.
Okay, so if it's negative or positive, it always ends up becoming positive, right? Okay, and does anybody know why that happens? Why a positive stays positive and why a negative becomes positive? So what is it about absolute value that, if you had, as you can see here, absolute value of +3 became +3, absolute value of -3 also becomes +3. So what makes it do that? What's that concept with absolute value?
Isn't it just that it's based on its distance from 0? It isn't based on a sign.
Yeah, very nice, Noah. Exactly, because you do think about, yes, Isaac, you think about absolute value as the distance of that number from 0. So if you put this on a number line, we've got 0 in the middle, we'll have +3 on the right, -3 on the left. So the idea is, if you're just talking about the distance from 0 to 3, we are saying, well, that's a distance of 3 units. It's only 3 units away from 0. If you, again, same thing, talk about the distance from 0 to -3, well, that distance will also be 3 units. So when you think about this in terms of distances, we don't really use negative distances. If we were talking about, going from Greeley to, let's say, Denver, we wouldn't be saying, you're going in the negative, whatever, 50 miles direction. We would most likely say, go 50 miles south on I-25 or something like that. So maybe we would add a direction in there, but we don't really say a negative distance. So that's the same idea with absolute value. And you will see we are defining absolute value here as, if it's a positive number, then absolute value of x will stay x. If it's a negative number, then you're actually taking the negative of that number. So that's what's happening here. When my x was -3, we are taking a negative on that -3. So negative times negative ends up making it positive. So if it's a positive number, it stays the same. When it's a negative number, you're basically multiplying it with a negative sign to change it into a positive. Or, like I said, think about it as being a distance, and a distance is always going to be positive. Now, when it comes down to solving absolute value equations, there's 3 different scenarios we have to consider. So you can have an absolute value equation of the first type, where you have absolute value on one side and a positive number on the other side. So if that k is a positive number, then we actually break it down into as x equals -k or x equals +k. And usually in this situation, you end up with 2 different solutions. You can also have a second type of absolute value equation, where your absolute value of x could be equal to 0. So in this case, you only set it up as x equals 0. And they're talking about the solution set as being 0, but technically you should only have one answer coming up from this type of an equation. Now, your third scenario here is, what if you have absolute value on one side and a negative number on the other side? Now, we are basically saying absolute value of x equals a negative number. So you can kind of think about it something like this. Now, we are saying that the distance of x from 0 is -5. Now, remember what we just talked about. If we're talking about a distance from 0, no matter which direction you are going in, your distance is always going to be a positive number. So there is no way that our distance is going to be -5. Now, if that was +5, then yes, we could be on the right-hand side or left-hand side. But when they say your distance is negative, you're not going to have a solution in that case. So that's why for that last case, you actually have an empty set, because there is no solution when your absolute value equals a negative number. So just to make sure, again, you guys are comfortable solving examples like this, let's take a look at some of these examples. We'll go ahead and start with this guy. So what do you think, if we solve this, what kind of solution set would this one have? So you give an absolute value of 5x minus 11 equals -18. Okay, go ahead, send your answer. Oh, it shouldn't take you that long on this one.
Didn't you just say that an absolute value can't equal a negative number, so there's no solutions?
Yeah, exactly. It does not matter that you have that 5x minus 11 inside of the absolute value symbol, because again, that is all that absolute value quantity, and you do have a negative number on the other side. So this guy is your classic example of distance cannot be negative, so there is no solution to this equation. So don't let that absolute value of 5x minus 11 throw you off, because that does not affect the fact that you have a negative number on the right hand side. Okay, so let's do a quick check on this guy. Alrighty. Okay, let's solve this one. So as you can see, we've got 4 multiplied with absolute value of y plus 3 minus 32 equals 0. So the first thing we actually have to do here is isolate that absolute value of y plus 3. We always want to get that by itself on one side, which means we will need to get rid of this 4 and this 32. So that will end up giving us, basically, we will need to start by moving that 32 to the other side. We'll go ahead and add that guy first. Then you are left behind with 4 times absolute value of y plus 3. And since we're multiplying that 4 into the absolute value, of course, we will divide it on both sides, which will end up giving us just the absolute value on one side. And of course, 32 divided by 4 will give you 8. So this is now where you have isolated the absolute value on one side and you have 8 on the other side. So remember, this is where, this was the first scenario we talked about. So when you have a positive number, you need to set it up as x equals negative k and x equals positive k. So this is what we will be doing. So that means you will take y plus 3, set it equal to positive 8, or y plus 3 equal negative 8. And as you can see, from each of those equations, you'll get one answer. So you should have a total of 2 answers coming from this example. So go ahead and solve those 2 equations. And again, just type your answer, but don't send it in till I ask you to. Okay, go ahead and send it in, guys. All right, let's see, I've got 5, negative 11, 6, negative 11, negative 11, 5, 5, negative 11, okay. Raylan, looks like you've got 5, negative 12, negative 11, and 5. Alrighty, let's do a quick check over here. Then of course, we would getting the y by itself, so move that 3, which will looks like we do actually end up getting 5 on this side, 8 minus 3. And then on the other side, you're still subtracting that 3, but because now that your 8 was a negative number, that negative 8 and negative 3 will end up giving us negative 11. So yeah, very good, 5 and negative 11. So I'm thinking it was just maybe a quick miscalculation for those of you. The one I had with the 6 and the other one was a negative 12. All right, let's do, again, just a quick check over here. So we've got negative 11, comma 5. And you're literally just using a comma to separate the two answers. So no space or anything like that. Just put a comma between the two numbers and you are good to go. Alrighty. Okay, yeah, here's actually another example which is not in your handout, but it's actually not too bad of an equation to solve. So any idea where you would want to get started on an example like this? You've got x minus 3, the whole quantity squared, and then that's equal to x squared minus 6. So if you had to get started on this example, where would you begin?
When you want to factor the square, so it's like one all laid out on the left, or is that wrong?
Are you talking about factoring the left-hand side?
Or not factoring, but like multiplying the square out.
Yeah, very nice, Elijah. Exactly. So you do want to go ahead and multiply that left-hand side. And remember, this is what we call as FOIL when you're trying to multiply two binomial terms. So for that left-hand side, and I'm going to use my little notebook over here to walk you through the steps. So on the left-hand side, we're actually doing, we're going to do FOIL here. So that's going to be taking our x minus 3 quantity squared and basically laying it out as x minus 3 multiplied with x minus 3. Now remember, FOIL basically means you are multiplying the first terms, the outer terms, the inner terms, and the last terms. So that would be x times x for the first, which will of course end up giving us x squared. Let's see, for the outer terms, you're multiplying x from the first parentheses and negative 3 from the second one. So that would be negative 3x. The inner terms would be negative 3 from the first parentheses, x from the second one. So that's again negative 3x. And the last would, of course, be the two negative 3 terms. So negative times negative becomes positive. Of course, 3 times 3 will become 9. Combining those two middle terms, we'll end up with x squared minus 6x plus 9. So this is what our left-hand side will become. And then we've got x squared minus 6 on the right-hand side. All right, what are you going to do next? So after we've simplified the left-hand side, where would you go next?
You subtract the x squared from both sides to get rid of them?
Yeah, very nice, Tessa, exactly. So we'll go ahead and subtract that minus x squared, move it to the left-hand side, and these guys cancel out, which is really good because now we don't have to worry about that second degree term, and you are just left with minus 6x plus 9 equals, looks like minus 6 on the right-hand side. And then again, you're just trying to get that x by itself. So go ahead and get the value of x. And when I ask you, you can send it through the chat. And I think, let me just check very quickly, but they are again asking for a simplified answer. They're not specifically saying decimal, so don't leave your answer in the decimal form. Keep it in a simplified fraction form. Or if you're getting a whole number, then of course you don't even have to worry about that. All right, guys, go ahead and send your answers in. Okay, so it looks like we are getting a fraction. Elijah, you've got negative 15 over 6. Daisy, Michelle, you've got 5 over 2, okay. 5 over 2, Raylan. Jacob, you've got negative 2.5, 15 over 6, 5 over 2, negative 15 over 6. Okay, so you definitely want to reduce your fraction for those of you who've got the 15 over 6, because obviously both 15 and 6 will have 3 in common, right? So let's go ahead and move this 9 to begin with. Let's cancel out. And let's see, we are left behind with, come on, buddy. There we go. We just saw something coming through on chat. Come on. Elijah, you guys have 5 over 2 now. Okay. Yeah, so as you can see, we've got negative 6x equals negative 15. So when you move that negative 6, you will notice that negative sign will cancel out because a lot of you had that negative remaining on your answers. So the two negatives will become positive and you're left with 15 over 6. But as I said, both of those numbers can be divided by 3. So 15 goes into 3 5 times, and of course 6 goes into 3 2 times. So make sure you are reducing your fraction, because if you don't, MyMathLab will not accept the 15 over 6. They are going to want you to simplify your answer. All right, so let's go back here and check our answer very quickly. So that's going to be that first one, 5 divided by 2. And there you go. Okay. Just something to be careful about when you're working through these examples. Again, just another example that has rational terms in its in the problem. So again, my recommendation would be, if you're comfortable, get rid of the denominators. I know some of you have seen different techniques when you've done other math classes. So if you have a different technique that you're more comfortable with, I'm okay if you use something different than what I am showing you, because ultimately the idea is you should be comfortable with what you're doing and, of course, getting the correct answer. So just again, you can kind of see what you need to do in that. Here's another example for your absolute value equation. And you will notice, like the previous example we did, again, our first step here has to be to isolate that absolute value expression, move everything else to the other side. So we need to move the 9, we need to move the 4 to the other side. So like I showed you before, go ahead and get that absolute value of 4x minus 3 on one side, move everything else on the other side, and see what kind of equation are you coming up with. Because remember, there's 3 scenarios. You can have a positive number on the right-hand side, you can have a 0 on the right-hand side, or you can have a negative on the right-hand side. And then depending on what you have those 3 different ways of solving it. So go ahead and isolate that, and let's see what that gives us. Okay, looks like you guys are done. If you will go ahead and send your answers in, please. Okay, I've got Elijah saying it's C because it doesn't work, so you've got an empty set, okay? What did the rest of you get? I've got 3/4 from Maka, C from Teddy. Michelle, you're also saying no solution. C from Chloe, Jacob. No solution from Logan and Maxiel. C from Keshla and Tessa. Olivia, no solutions. Okay, so it looks like you guys are kind of going back and forth. Well, actually, C option is an empty set, isn't it? So it looks like all of you are saying no solution. All right, let's take a look at this very quickly since all of you have got C. Now remember, the only way you can get C is if you had a negative number on the right-hand side of your absolute value. So let's see, we've got 9 plus 4 multiplied with the absolute value of 4x minus 3. And that equals 9. So if I subtract 9 on to the other side, that will actually end up giving me, let's see, 4 multiplied by 4x minus 3. So 9 minus 9, of course, will be 0. And then, Raylene, you've got 3/4. And I know, Maka, you also had 3/4 as your answer. Now, again, we still need to isolate our absolute value, which means divide both sides by 4. And this will end up giving you absolute value of 4x minus 3 equals 0. So you're not getting a negative number on the right-hand side. So definitely option C is not going to be your answer. Because remember, when you have 0, and again, just very quickly, you can look at your handout for this section. And you can see when you have a 0, you actually set it as x equals 0, and then you can solve your equation. So that's what we need to do here. Oops. There we go. Okay, so all we will be doing now is just get rid of that absolute value symbol, and you just have 4x minus 3 equals 0, and then you're getting your x by itself. So of course, start by adding that 3. Then we divide by 4, and you can see we do in fact end up getting x equals 3/4. So only time you would get option C or no solution is if this right-hand side was going to be negative, okay? Alrighty, so all we gotta do is a quick check on our example. So this will be option A, and 3/4 is what we should have. Did any of you have a question on this example here? So did you see why it would not be option C or no solution? Yeah? Okay, if anybody has a question, don't hesitate to ask me, okay? Alrighty, let's see, what is this last one over here? Okay, yeah, this last one is kind of like the other examples you have seen with the rational expressions involved in them. So for this kind of equation, there's actually 2 different ways you can solve this. The first one would be like we did before. You can find your least common denominator and then multiply the entire equation by that. So if you do the least common denominator, of course, that means you are taking both of these denominators over here. So we've got x plus 1 as one of the denominators and x plus 3 as the other one. So you would need to take both of those denominators, and then, you know, of course, we would end up multiplying the entire equation by this least common denominator. So what would happen in this case, when we multiply our equation by the least common denominator, on the first left-hand side, the x plus 1 will cancel out, leaving us behind with just x plus 3 over here. And on the second side, the x plus 3, you know, would basically cancel out, leaving us behind with x plus 1. And then, of course, we would need to multiply those expressions and move forward. So that's one way of doing this. Now, if you notice, this particular example is, you know, just one fraction on the left-hand side and one fraction on the right-hand side. Now, the other examples we looked at were actually of this form, where you had one fraction, then maybe a number, and another fraction. So in this case, you definitely have to use the least common denominator to simplify this, but you know, in our example, we don't actually have a term like this available. So all you have is one fraction on the left, one fraction on the right. So this is actually of the form A over B equals C over D. So, you know, you can actually use the idea of cross multiplication also. Now, this will not work for other examples, but it will definitely work for this one. So instead of doing the least common denominator, you can just use cross product, and that will also get you to the same result. So in cross product, we will end up multiplying x minus 2 with x plus 3. And then on the other side, we would be multiplying x plus 5 with x plus 1. And then, you know, of course, since these are both binomial terms, we will need to do FOIL on the left-hand side, and we would need to do FOIL on the right-hand side. And once you simplify both of these sides, you would combine like terms, and your ultimate goal would be finding x. So you should be able to come up with what the value of x is going to be. So just follow these steps when you're working through your example, and you should be able to come up with some form of an answer for this. So that would be my recommendation for this last example over here. But again, remember, if you are comfortable with doing the least common denominator part of calculation, you can use that also. So remember, all the other examples, you will be able to see them in your video lectures. So just use that process to help you solve some of these other examples over here. Okay, so the other section we wanted to talk about today was going to be 1.2, but I did want to point out something here in your handout. You actually do have an example here talking about modeling real life situations. The only difference is with this example, they're actually giving you the equation for this situation over here. They're giving you the necessary information, and then they are saying, okay, find out in what year will the women in the US will have a median income of $25,000. So in this example, like I said, they are giving us the equation, but when you move on to section 1.2, this is actually where they're asking us to construct the models, which means we have to come up with the equations on our own. So a lot of times, you know, the idea is, can you fall back on a known equation? So, you know, known equations could be something like our distance, rate, and time formula over here. They could be area formulas for, you know, rectangles, squares, triangles, you know, some of those common shapes that we see. So if you can use a known formula, definitely we want to do that. But if we don't have a known formula for the situation that's given to us, then, you know, we want to kind of see what's given to you in the example, and are you able to come up with an equation just by looking at the example. Now, one way to remember this distance, rate, and time formula is to remember the word dirt, because that shows you the order of these variables, DRT, and of course the I will basically just become your equal to symbol. So you have the distance, rate, and time formula. Like I said, you've got your area, perimeter formulas, any of those could come in handy. So the first part we're actually starting out with is where you should be able to rearrange your formulas, where, you know, maybe instead of distance, we were interested in finding the rate, or if it's an area formula, maybe you're interested in finding the length or the width instead of the area. So if they're asking us to solve this equation for R, that means they're asking us to get R by itself. So we would need to get rid of that T, and we can do it by division. So you would end up getting D divided by T equals rate, because that's distance over time, which would give you rate. Same thing over here, they're giving you the equation of a line, and they're asking you to get Y by itself. This example over here is actually giving you numbers, but again, they're asking you to find, you know, the length of base 1. And this is actually the formula for the area of a trapezoid. You know, when we're talking about a trapezoid, you're kind of talking about a shape like this, where these two are your bases B1 and B2, and the perpendicular height between the two bases is what we call as the H. So they're basically just using the area formula for a trapezoid over here. So those would actually be some of the first things they will have you do in this section over here for 1.2. You can see some of our first initial examples are going to be all about like this. So this one over here is asking us to rewrite this formula basically by getting Q by itself. So you're trying to isolate the Q. So why don't you try and see if you try to get Q by itself by moving the 27 and 7/6 to the other side. Out of these four options, A, B, C, and D, which one is going to be the formula when you rewrite it for Q? So then just put your answer in the chat and send it when I ask you to. You guys go ahead and send your answers in. I've got B, I've got A, B, 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 D, a D. Okay. Got B's, I got another B. Okay. D. Alrighty, so let's take a look at this guy over here. Then you are given N equals 7/6 times Q plus 27. So we're of course trying to get Q by itself. So we can start by subtracting 27. Okay, I've got a couple more D's coming through. These guys will cancel out, leaving us behind with 7/6 Q and N minus 27 on the other side. Now 7/6 Q is being multiplied into Q. So you can think of it as 7 being multiplied into Q and 6 being divided. Or if you just take that entire fraction, then remember how you can invert the fraction and multiply it on both sides of your equation, which would be the easiest way to do here. So this way your 7 and the 6 will cancel out, leaving us behind with the Q, and you will notice this will end up becoming 6/7 N minus 27. So I know one of you had option A, so the only thing you have to remember, the reason option A doesn't work is because we first did N minus 27, so that is one quantity now, and the 6/7 is being multiplied with that entire quantity. So this had to have parentheses, and since it does not have parentheses, that's the reason why A does not work. A couple of you had B as the option. So B as the option, you can see they're leaving that fraction as 7/6, but you know, to get rid of 7/6 from the right-hand side, we do have to invert it. So it will end up becoming 6/7. So that's why option D is the one that makes sense. Okay, so we'll do a quick check of our answer over here. Come on, buddy. There we go. Okay, so this is just rearranging your equation, and you've actually got a couple more examples on this in your homework. So just asking you to rewrite the formula for one of the given variables. All right, now let's take a look at how to solve this equation over here, or this formula. So they're giving us the formula of converting Celsius to Fahrenheit, and they're asking us to see what would negative 30 degrees Celsius come out to be in Fahrenheit. So obviously that means in the formula, you're going to be plugging in that negative 30 for C. So let's see what kind of answer you guys get for degrees Fahrenheit over here. And again, don't send the answer till I ask you to. Be careful because this is a negative temperature, so don't miss that negative sign. Okay, looks like most of you guys are done. All right, go ahead and send your answer in, guys. Okay, let's see, I've got negative 22 degrees Fahrenheit, negative 22, negative 22, okay. Negative 22. Alrighty, so your Fahrenheit is 9 over 5 multiplied by degrees Celsius, which in this case would be negative 30, plus 32. So again, negative 30 was a nice number because 5 will go into 30 evenly. So that would, of course, end up becoming a negative 6. When we multiply 9 times negative 6, we get negative 54. And then by adding that 32 is what actually brings it down to, yeah, negative 22 degrees Fahrenheit. So you can see that's a pretty cold temperature. And if you're aware of the Celsius scale, on the Celsius scale, 0 degrees is the freezing temperature, right? So you are talking about below freezing when you're talking at negative 30. And of course, you can see even when we convert it to negative 22 degrees Fahrenheit, I mean, that's really, really cold. So again, we'll do a quick check over here. So negative 22, and we should be good to go. Now, the next set of examples is actually where they get into these applications or, constructing our own models. So just to quickly go through the steps that are involved when we are constructing our own models. Of course, the first thing is, make sure you're reading the problem. Depending on what kind of problem it is, it may require, multiple times to read it. We want to make sure we're understanding the problem, we're understanding what information is given to us, what they're asking us to find. If it helps, you can draw a diagram so you can kind of visualize the problem. So you can see in some of these examples, I have included the illustration so it becomes a little bit easier to visualize, what we're talking about. Choose your variable. Now you can use X or any other letter maybe that represents the example, but make sure you choose the variable and then write down what that variable represents. So are you trying to find like the height or the length of something? Are you trying to find the quantity of something? So if you define what your variable stands for, then of course it makes it easier when you go back and see, okay, this is what X was supposed to be. Now, if you have any other unknown quantities, don't introduce a new variable. So don't do like X for one quantity and Y for the other one, because the more unknown variables you bring in, the harder it's going to be to try and solve that problem. So if you can take other unknown quantities and write it down in the same term as that first variable you selected, so what happens in that case, you just have one variable that you are working through, and then we'll be able to calculate and get all the other unknown quantities based on that variable. So try and just use one variable. Then of course, once you have that, you want to write your equation down. So write an equation that would model the situation. Like I said, if you needed to use known formulas, you can do that, or see what information is given to you in the problem that you can create an equation based on that. And then of course, we want to solve the equation after that. We want to check our answer to make sure it's answering the original problem and not the equation. So what was given to you in the word problem itself. And then, of course, finally, make sure you're answering the original question that was given to us in the problem. So you do have a lot of these examples that you have in your homework are going to be the ones you see in your handout also. So you can see this one here is definitely in your handout, so you should be able to follow that along. This example is just a little bit different than the one I have in the handout, but this one is actually talking about trimming this garage over here. So they're talking about this carpenter used 42 feet of molding to trim the garage door. So they are saying the longer piece was 2 feet longer than twice the length of the shorter piece. So again, if you look at this image that they have over here, we've got our shorter piece, and you can see they're already calling it X. We've got another shorter piece over here, which is the same length as the other one. So this will also be X. Now for this longer piece, they are actually giving us this little description over here, which says the longer piece was 2 feet longer than twice the length of the shorter piece. So think about this, and I will try to bring this on one page. But basically we are saying the shorter piece is that length X, which is given to us. So what would you do to define this longer piece? How would you write that down? X is the length of the shorter piece. And then for the longer piece, how would you write that expression down? Because they're telling us the longer piece is 2 feet longer than twice the length of the shorter piece.
That would be 2 plus 2x.
Yeah, very nice, Michelle. Exactly, because they're telling us it's twice the length of the shorter piece. So twice means it's going to be 2 times the length of the shorter piece. And then they're saying additionally, it's 2 feet longer than that. So that's going to be an addition of 2 more feet to that. So you're basically taking twice the length of the shorter piece and then making it 2 feet longer. So this is kind of what they meant when they said, take one variable and use that to define your other unknown quantities here. Okay, so we've got the 2 definitions for our shorter piece and longer piece. We know the carpenter is using 42 feet of molding. So any idea what our equation would end up looking like for this example here? So how would you set up your equation in this case?
So on the sides, you'd have 2 X's. So then and on the top, you have 2 more X's. So you have 4 X's, and you have your plus 2.
Yeah, very nice, Noah. Alrighty. So exactly, because of course, we're going to be adding all 3 of these sides, and that should, of course, add up to a total of 42 feet. So you've got X and X for our 2 shorter sides, and then we just defined the longer piece as 2X plus 2. So all 3 sides together will add up to your 42 feet of molding. So go ahead, find your answer for X. Now remember, your X is going to be the shorter one. They're asking us to find both the long and the short piece. So you will be sending me 2 answers for the shorter length and the longer length. And again, just don't send your answer till I ask you to. So just get your answer ready. And when I ask you to, then you send it. It's okay. So 2 answers, okay? One for the shorter length and one for the longer one. So you can just use a comma to put the 2 answers in. All right, guys, go ahead and send your answers in. So I've got 10, 22, I've got 10 and 20, 20 and 10, 10 and 22. Okay, so it looks like 10 is definitely the shorter length you guys are coming up with, but then you've got 20 or 22 for the longer one. Okay, so yeah, as Noah had mentioned, you know, when you add all those x's together, you'll end up getting 4x plus 2, which is 42. So we subtract that 2 on both sides, which will end up giving, okay, looks like Jacob and Michelle, you guys are correcting your answer. Will give us 40. 4 divided into 40 will, of course, end up giving us x equals 10, which was, of course, for our shorter piece. And then to find the long one, you're just plugging that into our expression 2x plus 2. So yeah, this guy will end up giving you 22 and not 20 as the answer. So that would be 22 feet for the longer piece. All righty, good job, guys. So let's see, just be careful. The only mistake I have seen mostly happen in this example is, you know, students will end up switching the answers. So the first one here is talking about the longer piece, which is of course 22. And then our shorter piece was 10. So we'll do a quick check over here. And there you go. All right, wonderful. So like I said, some of these examples are going to be in your handout, and the ones that are not particularly in your handout, I'm kind of helping you go through those. This one here is talking about, you know, Fitz is planning on fencing a square feet lot and then cross fencing them into 4 smaller lots. So this is actually very similar to this example over here. So if you follow the video lecture for this example, you will be able to simplify this one over here from your homework. This example here is talking about how Trent can deliver newspapers in 10 minutes. Lois will take 40 minutes. So the idea is if they were to work together, you know, how long would it take them to get the job completed? Now, these type of examples are what we call as work examples, and I've actually included one here in your handout also. So the idea behind work examples is, you know, is it more efficient to have one person who works faster, or is it, you know, more efficient to have more people do the same job? Now I picked this example of Batman and Robin, you know, clearing up crime in Gotham City, and I just thought it was a goofy example, but you know, obviously it still helps us understand the concept of work problems. So a lot of times you will see these kind of examples, you know, the one in your homework right now we're looking at is talking about delivering newspapers. Sometimes they will have about, you know, what if, you people were raking their garden or, mowing a lawn or something like that. But some other examples I have seen is where they actually talk about machinery instead of people. So they may say, is it more efficient to have, two printing machines doing the job? Or if it's like a water pump, does it make sense to have two water pumps instead of one? So, these type of examples can help you if you are, kind of in the situation where you have to imagine, do we need to bring more machinery in? Do we need to bring more people in? Is it going to be more practical doing it that way? So this kind of just sets up the basics for that. So again, remember, this is what we call as word problem. So if you follow the example from this Batman Robin in your video, you should be able to, work through this one in your homework. Now, you do have a couple different examples here on what we call as mixture problems. So this last one, which would be number 12, you do have a similar example to that. Oh, wrong window. There we go. You do have a similar problem like that here in your handout again for your video lecture, so you can follow that. But I did want to talk about this example over here. So as you can see, this one is asking us how much water should be added to a 8-liter solution that contains 5% extract of baneberry to get a solution that contains 3% extract of baneberry. So in this case, we're actually not mixing two different types of solutions here. You're actually just bringing the concentration down from 5% to, what did they say, 3%? So if you're trying to bring the concentration down, obviously we're just diluting this by adding water to it. So the approach for this problem will be a little bit different than number 12. So in this case, of course, they're asking us to find how much water needs to be added. So that would definitely become our unknown quantity. So you can say X is the quantity of water, which again, keep in mind is going to be in liters. Now we are starting out with a 5% extract of baneberry solution, and they're telling us we have 8 liters of that solution. So that's a 5% concentration, and we have 8 liters of it. We are trying to reduce it down to a 3% solution, right? Now we are starting out with 8 liters of this solution, but you are adding water to it. So what do you think will happen when you add water to it? Will it still be at 8 liters? No, right? Because by adding water, you will definitely be increasing its quantity also. So that's why, since we're diluting it to make it a 3% concentration, you're actually adding whatever amount of water you will be adding to it to bring it down to that concentration. So the 5% is at 8 liters. That will stay as it is. But now we are trying to make it into a 3% concentration. So it's going to be 8 liters plus whatever amount of water you put in. Now, the other thing you have to remember when you're working with percents in problems, you always want to convert your percents into decimals. So 5%, take 5, divide by 100, take 3, divide by 100, and you will have your decimals, or, you're basically just moving your decimal 2 places to the left. So 5% will end up becoming 0.05 multiplied by 8 equals 3% will of course become 0.03 multiplied by 8 plus x. So go ahead and solve this, and let's see what value you come up with for x. And again, in your instruction, guys, they're asking us for an integer or a simplified fraction as an answer, so not a decimal answer. And again, don't send your answer in till I ask you to. Okay, if you are ready, go ahead and send your answers in. We have got 2 liters, 16 over 3. Okay, 16 over 3. Let's see. So you've got 5.3, Michelle, which again, you would just need to convert that to a fraction. But let's see, Jacob, you've got 1 and 3/5, which would actually end up becoming 8/5, which looks like it's different from the 16 over 3 that the rest of your classmates got. Okay. So let's take a look at this guy then. You've got 0.05 multiplied by 8, which of course will just end up becoming 0.4. And then on the other side, you would be distributing that 0.03. So first we multiply it by 8, which would give us 0.024. So we're taking this number, multiplying with both our terms. And of course 0.03x. We will go ahead and subtract that 0.24 on both sides. Which should end up giving you 0.16. Okay, so now to get x by itself, you are dividing both sides by 0.03. Now, since they are specifically asking us for a simplified fraction or integer answer, right now we've got 0.16 divided by 0.03. So if you will notice, both of these have 2 decimal places in them. So if you just move that decimal place 2 places to the right, you can actually convert these from decimals into whole numbers. So that would, of course, end up becoming 16 over 3, which is what most of you came up with. Now, if you were just to do 16 over 3, you know, of course, as a decimal, you would end up getting 5.33 repeating. And, you know, since they don't want us to give them decimal answers, you know, we're not going with this one. So you're just going to write 16 over 3, and remember this is in liters, as your answer. I know one of you gave me 2 liters. So just please go back and check your math because looks like something got left behind or, you know, something got miscalculated. So let's do a quick check over here. And you know, sometimes you can actually just use your calculator. So even if you've got 5.333 repeating, you should be able to change it from a decimal to a fraction mode in your calculator. So if you know how to do that, you can obviously use your calculator to your advantage also. So any questions on this mixture problem over here? Okay, so like I said, for the last one, number 12, you will be able to use the example from your video lecture to help you simplify this one over here. Okay, so let me go back to your course shell over here. I've actually already made a note about what we will be talking about for our next lecture, so you should be able to see this first announcement. So we'll actually be going over sections 1.3, 1.4, and 1.5. 1.4 is actually just a review section. So if you notice in your homework, in my math lab, you don't actually have homework on 1.4. And of course, you will not be tested on questions from 1.4 either. It's just that the concepts that we have in 1.4 are going to be, you know, used in other sections. So we will just review 1.4, but like I said, you don't have to worry about testing or anything like that with section 1.4. So just make sure for the next class, which will be Tuesday morning for us, you guys are looking at the video lectures for 1.3, 1.4, and 1.5. And again, please don't fall back behind on your homework. If you haven't started your homework yet, please go ahead and get started, okay? So any questions, guys, before we dismiss class? Are you guys all feeling okay about the class so far? Okay, if you have any questions, do let me know. Go ahead, Teddy.
I don't know where to find the videos because I saw that we only had one video.
Oh, you want to look at either the video lectures from summer or spring.
Oh, okay, yeah, okay. I'll make sure.
And I would say maybe summer, if you don't want to go too far back to the spring classes, you can do the summer ones. Okay. Any other questions, guys? Okay, if not, then I will see you on Tuesday morning. Everybody have a wonderful weekend. Stay safe. Bye, everyone. Take care.
Have a good one.
You too. Bye-bye. Bye, guys. Bye.